When speaking about DFS, depth first search, there's a couple of things that I have to tell you. So DFS finds the longest path inside of a graph. So now the data structure inside of the breadth first search algorithm was a queue, but in depth first search you're going to be using a stack, okay, because of its recursive nature and yeah, basically because you have to backtrack. That's one thing. When you are coding or actually dry running for a DFS algorithm and you create an adjacency list, sometimes your question asks you that you have to give priority to the lower number over the higher one. In that case, what you're going to do is when you create the adjacency list, then your node is your nodes that are connected to us, assume number 1 or node number 1 should be 2 3 7 9. So they should be in ascending order. They shouldn't be like 7 9 2 3. Okay, that's just something I had to clear up. Now because this is using a stack, it's recursive in nature. Okay, so DFS works like this. Your starting node is going to be 0, so we're starting at 0. Okay, look at the adjacency list. You don't really need to look here if you have the adjacency list. You're going to see that 0 is connected to 8, right? So what you're going to do is you're going to do this 0, because yes, you're starting, and you're going to go to 8. Alright, once we're done with 8, you're going to now move into where 8 is, right here. Now you're going to go to 0, but because 0 was visited, okay, you're going to put the true, and you're going to predecessor, because we started at 0, the predecessor is going to be none. After that, okay, then you're going to come over here to 8. Then you're going to see 0 2 9. Now 0 is already visited, so you cannot go to 0 again. Now you're going to see 2. 2 isn't visited, so you're going to go to 2. Okay, now you're going to put by 2 visited, and you're going to make the predecessor of 2 8, because we came from 8. After going to 2, you're going to come see 2's first value, it's 1, and 1 is not visited, so you're going to come to 1, and you're going to make 1 true, and you're going to make it come from 2. Then you're going to see 2 is already visited, so you ignore that. Then you're going to go to 3. Okay, so you're going to make 3 true, and you're going to make 3 coming from 1, so you're going to go to 3 after that. Okay, so we're building in the longest path right now from 0, starting at 0. Alright, now basically what we did here is that we did 0 8 2 1 3, so we're at 3, and we can see that, yeah. Now you're going to come to 1, you're going to see that that's visited already, so you're not going to go there. Then you're going to go to 5, so 5 you're going to make true, and you're going to say it came from 3. Okay, so we are building here the longest path, right? So 5. Then you're going to see that 3 is visited, and then you're going to go to 6. You're going to see that 6 isn't visited, so you're going to make 6 visited, and you're going to say that 6 came from 5. So after 5 comes 6. Then you're going to come to 6, and you're going to see 5 is already visited, but 7 isn't, so you're going to make 7 true, and you're going to make 6. You make 7 coming from 6, so after 6 comes 7. After 7, you're going to see that you're going to put it into 1, but 1 is already visited, so you're going to come to 6, but 6 is also already visited. Now what do we do here? Well, when both of our nodes or all of our nodes are visited, you're going to backtrack. I'm going to use a different color, maybe let's use pink. Okay, so backtracking means you're going to come 1 back. Remember, when we return in a recursive function, that's the exact thing that's happening right here. Okay, so you come to 6, 7, there's no more nodes to go to, so you backtrack once again. You come back to 5. Alright, so now you see 5, 6, okay, so there's no more nodes to visit in 5 either, so you backtrack again. 3. So you come to 3, you see that there was number 4 we never go to, so now you're going to go to 4. Alright, so you're going to say true for 4, and you're going to say that it came from 3. Now here we're going to make another branch inside of our tree for DFS. Okay, and you're going to see it came to 4. Alright, and now 4 says that go to 2, but 2 is already visited, so you don't go there. And it says go to 3, but 3 is already visited. Remember, 3 is visited, so you don't go there. So now there's no more nodes remaining, so you do something called backtracking again. So you go back to the top, to the 3. Alright, so you backtrack again. Now since we're backtracking, Okay, you're gonna go back to the 3 and you see there's no more nodes, so you're gonna backtrack once again. Okay, you're gonna come to 1 and you see that in 1 9 is unvisited, so you're gonna make 9 equal true, and you're gonna say that 9, I'm gonna use a different color, maybe orange. Okay, so this is true, and now 9 came from 1. Okay, so after 9 you're gonna make here, you're gonna, after the 1 you're gonna make a 9, and now you're gonna see that 9 says go to 1, but 1 is already visited, then it's gonna say go to 8, and 8 is already visited, this is 8, so we don't have any more nodes left, so you're gonna backtrack once again like that. Alright, you're gonna go back to 2, and then since 2 is already visited, actually no, 2 says go to 4, 4 is visited, so you can't go there. Go to 8, 8 is already visited, so you cannot go, so you backtrack once again. Now you come to 8, 8, remember we stopped at 2, but now we're gonna go to 9, but 9 is already visited, remember we visited it there, so you can't go there. Now there's no more nodes to go to, so you backtrack once again, 0. So yeah, this is our tree. So yeah, thanks for watching.